So today we're going to go over angles of elevation and depression, and we will be using bearings as well. And this is all to do a bit of our application questions. So we're still looking at SOHCAHTOA mainly in solving them. So when you're going to remember, when you have the angle of elevation, it's actually always measured from the horizontal. Okay, so the angle of elevation, this is what we call the horizontal, when you go straight out from the line of vision. So there's the person's head and they go straight out. That's where the angle of elevation is, measured from that to the line of sight. So the line of sight is what joins the two objects together. So if we look at it, it would be like here. So that's elevation when you're looking up. When you look down, so from say this balloon down to the ship, that would be the line of sight, and here's the horizontal line. So when you're measuring the angle, it's from the horizontal to the line of sight. So we need to know this because they might give us in some worded questions. So we know that, but the angle of, when you have the angle of depression, it always equals the angle of elevation. So what I mean by that, see we have a little cat and we've got the tree, and you got your little birdie in the tree. So they're both looking at each other. If you looked at, the bird is looking down at an angle of depression, and just say that was 20 degrees, well, if the angle of elevation equals the angle of depression, so the cat, if the bird's looking down at the cat at 20 degrees, the cat's looking up at the bird at 20 degrees. So then we have a look here. So we said from a 3.2 kilometer high mountain, a car is 6 kilometers away, can be seen. So what you need to do is you should always draw a diagram of what's going on. So even if you just go, all right, here's the mountain, and they said that was 3.2, so there's someone up here on the mountain, and they can see a car that's, sorry, that's kilometers, 6 kilometers away. So over here, we've got our little car, okay? So they said, what is the angle of depression from the mountain to the car? So like I said before, so from one to the other, that's the line of sight. And then you have to measure, the angle of depression will be from the horizontal line. So that would be the horizontal line along here. So, but can you see, if I draw that line across here, wouldn't that be the same distance as from here to here? Aren't they the same?
Yes.
Would you agree? Good.
Yes.
So, can you see, when we do this, we end up with a triangle. So we want to know the angle of depression, which is this angle in here. Now, maybe going back, we should have, oh, we didn't write it. Go back to this question here. If this, so I'll just draw it. So here's our mountain, which we're going to say is 3.2 kilometers. And then I'm going to say the horizontal was 6 kilometers there. And here's our line of sight. But I just said that's the same. So if we want to know this angle here, it's the same as finding that angle there. Okay? So we can change that into a right angle triangle. So if I do that now, and I change, let's work out what formula we're going to use from SOHCAHTOA. So if you have a look, what word, I've got this side here. So what side would this be called? The opposite, adjacent, or the hypotenuse?
Adjacent.
It would, good. It's the adjacent. And what would this one be?
Opposite.
Opposite. So which formula has both? Good, TOA. So we would type that in. We go tan, or write out the rule. Tan angle equals O over A. Then you're going to write in what you know. So tan angle equals 3.2 over 6. So Harry, this would be all the stuff you're writing out. Yeah? And then you can,
I got removed from the call like 6 times.
and you can solve it on your calculator if you want, but because we're finding an angle, remember to do end solve.
Whoever's doing.
And we can do.
I checked as well.
Okay, so once we did that on the calculator, we're just going to say the angle was 28 degrees. Okay? And
How do you end solve? Like,
yeah.
How do you end?
Alright, so a pilot of a helicopter is flying 400 meters, at 400 meters. So what you've got, it's always good even if they don't, but they have asked us to draw a diagram. So you might have your chopper up here. Sorry, I'm not very good at this. Yep, there you go. And it's 400 meters above. So we're going to say that's 400 meters up. Okay. And it observes a boat at the angle of depression. So then we've got a boat somewhere down here. And they're saying that the angle of depression. So if you join the boats up, and then remember the angle of depression is that angle there. And they're saying is 1.2 degrees. So draw a diagram. So we have. And then it says to calculate the horizontal distance, which is this, between the helicopter and the boat, correct as the nearest 10 meters. So we'll just do that in a minute. So we've got to find this. So remember, if the angle of elevation equals the angle of depression, I can say this angle down here is 1.2, and I've created a right angle triangle. So if I draw out just in simple terms like what I've got as a triangle, this is what I've got. I've got X, and I know that, sorry, this is 400 meters, and I know this is 1.2. So let's have a look. What formula would I use if I've got the adjacent and I've got the opposite? So we're going to use, which one will, tan again, good. So I'm going to write tan angle equals O over A. So tan 1.2 equals opposite 400 over X. And then you can put that in your calculator, solve tan 1.2 equals 400 over X, comma X. And we're going to find that. So we've got a light on the top of a cliff top lighthouse known to be 75 meters above sea level. So always draw a little diagram. Even if they don't ask you, it's always ideal. So here's your little lighthouse, and they've just said that is 75 meters above sea level. It's observed from a boat at the angle of elevation. So you got your little boat down here, and they're talking about between it and the boat, and they said here's my, I'm going to say my horizontal, and they said the angle of elevation for that is 7.1 degrees. It says calculate the distance of the boat from the lighthouse to the nearest meter. So I reckon this is not very clear. Which one do you reckon it is? This one or this one? X or Y?
That one.
X or Y?
That one.
Yeah. I reckon it wouldn't matter. I would give you both because that's not really clear. They should say from the bottom of the cliff, or so we'll say it's this one. We'll use Y.
Who's kicking me?
So
so annoying. My head in.
If you've got the opposite, we've definitely got opposite, and we've got the hypotenuse. Which formula are we going to use? I'm going to write them up here again. Yeah, good. Sine. So I'll write that out. Sine angle equals O over H. Sine 1.7. Oh, sorry. 7 point.
You the opposite in the hypotenuse.
Yeah. And I write 75 over, we called it Y. And then you can go pop it in your calculator. Solve, comma Y. And you're going to get that distance there. So let's just. So the question said to the nearest meter, so we got it to be 607, yeah? 607 meters. Okay, yep. Okay, from a point A, a man observes the angle of elevation of the summit of a hill to be 10 degrees. When he walks towards the hill, for 500 meters along a flat ground, the summit of the hill is now 14 degrees. Draw a diagram to find the height of the hill above the level A to the nearest meter. So just if you're a little bit unclear, so this is the hill over here. Here's the hill. And here was where the little man was to begin with, and he walked that way to there. So this is my horizontal line along there. So that was the horizontal line. And because there was two scenarios, this is first his line of vision at the start, his line of vision, and then when he walks in closer, so which was 10 degrees, and then when he walks in closer, his line of vision is 14. Now, they tell us that he walks towards the hill 500 meters. So, what you, so I'm just going to rub that bit out. This little bit in here is 500 meters. So, if we have a look, we need to know, there's two scenarios. We've got X here. We don't know this little distance here. And we want to know, they want to know the height of this hill. Actually, I'm going to call it X. Okay. So, because we're at the moment, we're only using SOHCAHTOA. So, it means we always need to find right angle triangles. So, what I'm going to show you is we actually have two scenarios here. We have, this was when it's A, and here's the top of the hill, and this is C. Now, this distance along the bottom here is actually going to be 500 plus X, and you know that it's 10 degrees for that. Now, the second scenario is when you know, oh, sorry, probably shouldn't draw it as big. It's probably confusing. So the second scenario is when you have, he's at B, C, and H. So you've got, this is just X, this distance, but you know this is 14 degrees. Okay. And this is what we want to know. We want to know X. Okay. In both scenarios, this X is exactly the same because it's in between H and C. So even though we don't have all the information, see how we don't know what the X is. Oh, actually, I might change that to Y. I'm going to call that Y. Even though we don't know what Y is, that distance there, we can still work it out because when we can work out two scenarios. So what I mean by that, if I was going to find this out, pretending I did know what this was, I would say, all right, I've got the opposite side and I've got the adjacent side. And that means I'm going to use tan. So I go, all right, tan angle equals O over A. So I could say tan 10 degrees equals X over, and I'm going to write 500 plus Y. So here's the first scenario. And then if I do it for the bottom one, it'll be tan 14, because this is opposite over adjacent. It'll equal X over Y. And this is my second scenario. When you have two equations, see how we've got equation 1 and equation 2. When we've got two equations with the same two letters that we don't know, we can actually solve them in our calculator. And I'll show you how to do that now. I'll put some screen dumps in. If we go back to back here, we've done it on the calculator, and we know that X was 301 and Y was 1208. So the hill, the actual question was how high was the hill? The height of hill, which was X, is 301 meters. Okay, so this is how I'm going to set it up on the calculator. So on a normal calc page, I've pressed menu, and oh, actually I've gone to number 3, which is algebra. And then I've gone to number 7, which is solve systems of equations. And then I get this thing, and I'm going to pick this top one. It'll then bring you to this screen here, and you're going to say, yes, I've got 2 equations, leave that on 2, and you've got x and y. And then what that does on your calculator is bring up this solve, and it'll have all this. What you're going to do in the first, there'll be a little square box here, and that's where you'll type in this tan. You put your first equation, and then in the box underneath you put this, and you leave this bit here and you press enter, and then you can see we've got the answer. So the answer said to the nearest meter, so I'm going to say it was x was 301 and this was 1208. So 301 was x and y was 1208. So if we go back, so we found that using that.